We just finish up this question in the next video here. So we have drew our components, we found the components, we've added them up to get the totals. We've now drawn our vector tip to tail, and so now we're going to just determine the magnitude and direction of this, this vector. A couple of things that we noted in the last video. We know that fnet goes from start to end, right? So we know that fnet goes from start to end. And we know then that theta is always at the start. So at the starting vertex, that's where we're going to put theta there. So now what we're going to do is just look at how do we calculate the resultant of a vector. And so to do that, we're going to find the magnitude and direction. So the magnitude is the size of the vector, the length of it, and the direction is, of course, usually a compass heading, and that's what we're going to figure out now. So I have a right angle triangle. These vectors are right angles to each other, and so I can use Pythagoras then to determine the net force. Now the net force is the hypotenuse, and so I'm going to take the square root of the hypotenuse, and that then will take the square root of the other two sides. And so then I usually write my fnet equation to look like this. So it is the square root of the hypotenuse, which then is the square root of the squares of the other side. And so my fnet equation then looks like that. So when I put that onto the calculator, I would get an answer that is equal to 63 newtons. And that's called the magnitude of the vector, right? So if a question just asks for magnitude, then you're done. There it is, just the magnitude of the vector. Now we're going to get the direction of the vector. In this, I see that I have a direction that is in the opposite is north, and in the adjacent is west. So using the tangent ratio then would allow me to calculate the angle that is there. So I'm going to use opposite over adjacent as a tangent ratio. So to calculate the tangent of the angle, I will need to divide those two sides, and it's important that you get the order of the division correct, or else you'd be calculating the wrong angle. So opposite on top, 29.29, and 56.08 newtons on the bottom, like that. So once I have the ratio, then I can use the inverse tan of both sides. The inverse tan function, or arctan as it's called, then would be of this ratio 29.29 newtons and 56.08 newtons. It's important to note that these two units have to be the same. They must divide out because a trig ratio is a unitless ratio. And so I'm going to then fire up the Calcomatic and see what I get for an angle here. And that angle then is equal to, I believe it's 28 degrees. And so yeah, I get a 28-degree angle. Now I need to describe what its heading is. So I'm going to say something of something. To determine what this is your opposite side, and this is your adjacent side. So I'm going to put the direction of the opposite. So I see that the opposite direction is north. And so I'm going to put north there first, and then I see that the adjacent direction is west. And so then I'm going to put north of west as my direction. So putting that all together, then fnet is both a magnitude of 63 newtons, and it is a direction of 28 degrees north of west. So that's how you find the resultant, or the